Hi there, I am Darwin Davis, along with my team members, Mr. C.B. Vargas, Mr. Luis Arthur, and Alvin Burlado. We are Team Dasl here to demonstrate our environmental data logger with Wi-Fi. Our device measures temperature, pressure, and humidity and records these data onto a server through Wi-Fi. This data can be accessed remotely using a personal device such as a mobile phone or a computer. This device can be used by owners of parks, greenhouses, libraries, museums, industrial plants, and other spaces to monitor environmental parameters. Our environmental data logger is versatile with a wide sensing range and is compact and portable with a battery backup. Our system works on Wi-Fi and has a range of up to 45 meters and works through even walls made of bricks and wood. But when tested in an open space, we had a range of up to 90 meters. Do you have a very large project spanning over 100 meters? Don't worry, we still have you covered. Just install multiple devices and register them together on the same ThingSpeak account. Users can access data of individual devices or of devices as a cluster. Now, let us take a look into the technical specifications and the working of our environmental data logger. Mr. Sibi, my colleague, will talk further.
The data logger is capable of measuring temperature from -40 to 85°, relative humidity from 0% to 100%, and a barometric pressure from 85 kPa to 110 kPa. The system runs on a 5-volt DC adapter or a 9-volt battery installed in the system. The system connects to internet or Wi-Fi and stores the sensed data onto the server. The data can be monitored real time on any mobile device or a computer which is connected to the internet. The system has a human-machine interface. The HMI consists of an interface called ThingSpeak, where the user can log in and observe the changes in parameters graphically. The same data is stored in an Excel sheet, which can be used further for any kind of data processing or control system. As we can see, our system has a humidity sensor, a temperature sensor, and a pressure sensor. And inside our system, there is a power supply which converts 9-volt battery power into 5-volt useful power supply range for the microcontroller and electronic circuits. There are 2 microcontrollers inside our system. One controller is for processing the data, and the second controller is to connect with Wi-Fi to transfer the data to the server. As we can see on the screen, here there is a ThingSpeak screen. Here we have 3 graphical user interface where we show the information in the graphical form, the temperature, pressure, and humidity, and it's keep updating every 30 seconds. And here we have an Excel sheet. Here we have a date and timestamp and each channel data, temperature, pressure, and humidity. So as we are inside the room, the current temperature is around 15 to 20 degrees and humidity is around 40%. Barometric pressure is around 98 kilopascal.
This window here shows the database of the parameters logged onto the server. The temperatures are logged in degrees Celsius, pressure in kilopascal, and humidity in percentages respectively. The temperature logged at 123 on December 8th is 19 degrees Celsius, the pressure was 98 kilopascal, and the humidity is 41%. This is a recording of the parameters taken when the environmental data logger was placed inside a house. This is the ThingSpeak interface for the environmental data logger. Every 30 seconds, a new data is logged onto the server, and this can be seen on these following graphs. Each graph for the temperature, the pressure, and the humidity. Right now the temperature at 1:17 a.m. 25 seconds is 18 degrees Celsius. The pressure recorded is 98 kilopascal, and the humidity inside the house is 43% relative humidity. The data that is being logged, that is visualized, are the last 5 recorded data. This can be altered according to the user's need. For example, if you go into the options and change it to the last 10 settings, you can see the last 10 recordings. So accordingly, a user can change the number of points that he or she wishes to see.
So Alvin Borlado will explain about the outside temperature, pressure, and humidity. So we are moving outside.
Now we are outside. I will demonstrate to you the changes of the data logger. Now our system is in battery mode, and the system is connected to my mobile phone. As you can see in the data, the temperature drops to 0 degrees. The pressure stays the same at 98 kilopascal, and the humidity changes to 70%.
This is the mobile interface for the ThinkSpeak for our environmental data logger. As you can see, the temperature recorded is -4 degrees Celsius. The pressure is recorded at 96 kilopascal, and the humidity is 66% right now. Team Dasl decided to not just store data onto a computer through Wi-Fi, but rather on a cloud server in such a way that a customer could access data from any point in the world. Now, I invite my colleague, Mr. Louis Arthur, to conclude this presentation.
To conclude this presentation, the group will present the features of the product in this PowerPoint, that are the ability to work in multiple environments, being cost-effective to the end user, transmit data through Wi-Fi, so utilize Internet of Things concepts in the product, having a dual power source and having a human-machine interface. Here you can see the final product on its weather-resisting casing, and the block diagram of the circuit connections that shows that the sensors are connected to the microcontroller 1, PIC, and then PIC sends the commands through embed for the Wi-Fi module, and then the other way communication is received also from the Wi-Fi module to PIC. The sensor ranges were selected with Canadian extreme weather in mind, so are like displayed on this image. The prototype assembly was then like represented by this image, and the utilization of embed is for proof of concept of this prototype. If it's desired to continue the production of this product, it can be removed and then made only the system with ESP and PIC to be more cost effective to the end user. Regarding the human-machine interface, the server is sent on ThinkSpeak, and then after the data is received on ThinkSpeak, it's automatically sent to Excel, that on the right you can see where it's received, and then on the left you can see the graph representing. Thank you very much.